look at how to do probability where we're using those combinations and permutations we've been learning about. So when we're looking at events with lots of options, so lots of possibilities, something like the basketball play-in or a bracket for baseball, we have a lot of things that we have to count, and we don't want to create trees or diagrams or list out the options. So when we're doing that, we can actually use counting techniques like combinations and permutations to find the probability. So in this example, Stacy has the option of selecting 3 books to read for a humanities course. The suggested list has 10 options and 5 current event books. So 10 biographies, 5 current events, that's 15 total things she can choose from. She decides to pick 3 books at random. Find the probability that all 3 books will be biographies. So if I'm choosing at random, the order doesn't matter, so I can do a combination. And so if I want to know how many different ways I could choose 3 books from biographies because I want biographies, this would be choosing 3 from 10 or a combination. So we find that there's 120 ways to calculate that using the Web 2.0 calculator. So if I'm looking at 3 books from 15 options, because there's actually 15 things in the group, that would be 3 from 15, and I get 455 total choices. So there are 120 ways to pick 3 biographies. There are 455 ways to pick 3 books from a pool of 15. So to find the probability, I do 120 divided by 455, which is 26%. Here's another example. What is the probability of getting 4 aces when drawing 5 cards from a standard deck? So first I have to think about, I have 5 card hands and I need to have 4 aces in those 5 cards. So the key idea here is that I have to get all 4 aces in the deck, and there's only one way to do that. I've got to draw all 4 aces. After I have those 4 aces, then the 5th card could be anything. So there's 48 cards left in the deck that could be. So there is 1 times 48 possible ways to get 4 aces. Order doesn't matter because I just need to pick those 4 aces. It doesn't matter the order that I pick them in. And then the 5th card is kind of hanging out. So if I want to find the total number of options to pick 5 cards from 52, I'm going to do the combinations, and I get 2,598,960 ways. So I have 48 ways to get 4 aces and a 5th card. I have my total number of ways here. So I type that into my calculator, and it's a really small probability. That would be 0.00185%. So very, very small. And that's because I have a whole lot of options to choose from. So how would I use permutations then to solve probability problems similar to how I just used combinations? Combination locks are tricky because they're actually permutations. And a combination lock has 40 numbers on it from 0 to 39. Find the probability that if the combination to unlock it is 3 numbers, it will contain 1, 2, and 3 in some order. So right there, in some order, I need a permutation. Assume that numbers can't be repeated. That's going to be interesting. And so we're going to calculate that. And then in part B, we're going to see what changes if the numbers can be repeated. So for part A, I'm using a permutation because they told me order matters. I need to pick 3 numbers, 3 specific numbers they gave me, 1, 2, and 3. And so I'm doing 3 from 3 possibilities, which is 6. So there's 6 ways to pick those 3 numbers. So that means with order. Then if I want to think about the total number of ways for all the options, I'm picking 3 numbers from a bank of 40. So that leaves me with 59,280. So I'm going to do 6 divided by 59,280, and that gives me my probability. Now for part B, what's interesting in part B is if I can repeat the numbers, then that has no effect on the first part of the problem. I still can pick 3 numbers in 6 ways. So 1, 2, 3, 3, 2, 1, 3, 1, 2. That's what I mean when I'm saying pick 3 numbers. What it will impact is the total number of combinations for the lock. Because I can now repeat, I can use the fundamental principle of counting, which will be 40 times 40 times 40, which brings us to 64,000, which is slightly higher than what we had already selected. In this example, a store has 6 different fitness magazines and 3 news magazines. If someone buys 3 at random, find the probability he'll fit 2 fitness and 1 news. So in order to do that, I have to know how many ways they can choose from the 15. So there are 2 choosing from 6 fitness, because I need to choose 2 fitnesses. There are 6 total options, which gives me 15. Then I have to think about, well, how do I choose 1 news magazine? Well, I choose 1 from 3, and that gives me 3. So the use of and in this is a bit tricky because I want to pick 2 fitness magazines and 1 news magazine. So we can think of that as 2 steps. So pick the fitness, then pick the news. And so if we use the fundamental principle of counting, we're picking 2 things from 15 and 3, which is what I found using my combinations, which is 45 ways. Then if I want to think about how many ways can I pick the 3 magazines from the 9 remaining, that gives me 84. So the probability of picking 2 fitness magazines and 1 news, there are 45 ways to get what I want, which is 2 fitness and 1 news. There are 84 total options, which is 53.6%.